welcome to CATIA V5 Assembly Design Basics. To get started, I will open the case study model. In this case will be a Lego car. As you can see, this will be the demo part. I will also put the link for the file in the video description. And if you're gonna take a look at the model, our intent is to assemble all the Lego pieces. And after we have all the constraints defined, to be able to move the steering wheel, in this case will be on this axis, move the wheels, and also rotate the flag. So you can find the step file within the video description. And now, if you're gonna drag and drop that within CATIA, we're gonna see that the alignment of the car will be a little bit different. As you can see, using the default views, if I will go, for example, to the top view, I will see that the top view, in this case, it's actually a side view. So in order to fix that, we can select everything and rotate. To do that, I'm gonna select the Lego car product. Afterwards, I can make the compass snap to the object, select everything, and I will rotate everything on the y-axis. As we can see over there, we have that angle, so I'm gonna go all the way to 90 degrees. Afterwards, I will put the compass back. We're gonna check again that this should be the top view. And we see that in this case, our model still needs to be turned around 180 degrees. So in order to fix that, just select again. The last snap automatically to selected object is still active. That means that we just need to select the model, and afterwards we're gonna rotate it on the same axis, so it will be this axis, and I'm gonna snap this to 180 now, because we saw that initially we didn't properly align. Now this will be the top view. If I will go for the front view, will be the front of the car. So that is how you can manipulate and orient objects within CATIA V5. Now, to get started with the assembly, we see that this Lego car has a main product, but there are also multiple sub-assemblies. For example, the wheel are like this, so we have a sub-assembly for the wheel. I'm gonna change this, and I'm gonna go with all the components directly within the main component. So in this case, if you're gonna expand the wheel assembly, we're gonna see that this will have a wheel part and a tire part. So these are those two elements, and I'm gonna select those and drag and drop them onto the main product. The same for the tire, and as soon as I will do this, we're gonna see that all the other will disappear. That is because those were instances of the initial part. So now, in order to clear our assembly, we only want one large assembly and all the other components as parts. I'm gonna delete the wheel assembly by pressing the delete key. So there should be 4 wheel assemblies, and those are cleared. And we also have this flag assembly that will have the flag pole and also the flag. I'm gonna do the same with this, so have those selected and moved to the main component. Okay, now if you want to multiply those elements, so we're gonna need the tire and the wheel to be multiplied. We can make use of the feature known as define multi-instantiation. We see the hotkey Ctrl+E. So I can select the wheel. I can select also a tire, press Ctrl+E, and we're gonna see that we're gonna have the multi-instantiation pop up over here. We can define the axis where we wanna have those patterned. And in this case, I'm gonna position the other elements straight in a line. In this case, with the rotated car on the x-axis. And we can define the parameter either by instance and spacing or by the final length. In this case, I will go with something like 3 instances, since we need a total of 4 wheels, and the spacing will be 30. So So I'm gonna click OK. We're gonna see that only the wheel is currently selected for multi-instantiation. I'm gonna click OK. Afterwards, I will select the tire, press Ctrl E again, and the same parameters will apply as well. Now, to get started with the assembly, I'm gonna drag and drop the constraints over here. If for some reason you cannot find the constraints, you can right click over here and you can activate those. They will be under the constraints, so this should be that. As we can see, that will enable the constraints. If not, you can go to tools, afterwards customize, toolbars, and with the standard toolbar selected, if you're gonna click on restore position, this will rearrange everything within this existing workbench. In this case, as we can see, we're gonna have those aspects regarding various elements at the top. And what is important, after you reset the toolbars, you need to drag features. And over here, if the dragged features are aligned vertically, you can position them at the top and they will become horizontal. And it's important to drag features until you will see the empty ribbon. So now we know that everything that is associated to assembly design should be positioned over here. I also like to activate graphic properties over here, so I can change the color and transparency of the objects. Okay, now that you managed to identify the constraints, let's start with the assembly. So the first thing that we need to do is to define the fixed component. In this case, I will decide that the frame will be the fixed component, and we're gonna link everything to the frame. That means with the frame selected, I'm gonna go over here on the fixed component feature, and that will make that as a fixed component. Now, if I'm gonna zoom in on this, I will see that this part is slightly misaligned. If I'm gonna go on measure and I'm gonna measure the distance between those two, we're gonna see that there is a small gap between those pieces, and within the final assembly we are gonna, let's say, reposition that. So to get started, we have the frame, which we can change the color. So to make this more visible, I'm gonna select the frame and I'm gonna change the color to be green in this case. And now we need to add constraints between the frame and the other components. So I will go with coincidence constraint, and I will say that this edge from the frame should be coincidence with the edge on the top part. And as we can see, the part will be automatically updated. If for some reason this is not updating for you automatically, you can press Ctrl+U and that will update, or you can change within the options. We're gonna see that if I'm gonna go to mechanical design, assembly design, we're gonna have this update. And if for some reason for you it's set to manual, you can change that to automatic, so you no longer have to keep those updated. Now, we have the constraint between the frame and the top Lego block, but if I'm gonna try to manipulate that upper part, so go to manipulation, we're gonna see that we're gonna keep this checked with respect to constraints. And if I'm gonna try to manipulate this part on the y-axis, we're gonna see that the part will slide like this. So we need to fix that. So for each component, there are a total of 2 constraints that need to be added. Usually that will lock everything in place. So in this case, I can also, if we choose that edge and the top edge, in this case we can also use a plane, and we could have used a plane coincidence within the previous step as well. So that means that this plane should be coincident with this plane. We're gonna see that position over there indicated by the 2 arrows. The orientation will be the same. I'm gonna click OK. And if I will try again to manipulate that part with respect to constraint, I'm gonna see that on the y-axis I can no longer move that, and the other should be locked as well. And even if I'm gonna try to rotate, I'm gonna see that this will rotate this is why it's important to have usually edges as coincidence. Since we had that plane, we see that during this rotation, that constraint will still remain active. So this plane will be the same with this one, but at the same time I have the possibility to move this part which is not desired and intended. So I'm going to click on cancel to go to the previous area where I didn't manipulate any component, and I'm just going to add another constraint. That means that the top of that little component should be coincident with the top of that one. And now if I'm going to try to manipulate, that should no longer move on any axis. As we can see, if I try to move that along either axis, those components, those two will be fixed, since the main green component is fixed and the others is also constrained to that. So we're going to go forward with the constraints. So now if you have some overlapping parts like this, you can easily just use the hide and show. So that means I'm going to hide the inner part, and I know that this edge I will go at the bottom where we have swap visible spaces. That should be, okay, let's see, this is the component coincident with that one. And as we can see, that coincidence will be properly defined. And we can define another one. We know that this edge, let me just zoom in. If you're not getting the exact desired selection, you're gonna get a plane. You can zoom in and then you can select that desired element. And we know that that edge should be coincident with this one. And now if I'm gonna send that back, okay, let me undo that because I hidden multiple parts, so that I press undo. And if you also misalign some of the parts, you can always undo. You can check the last coincidence. We see that now coincidence 5 is the last one. And we have these components a little bit overlapped. That means that I'm gonna unhide that, unhide this as well. And I'm just gonna move this a little bit to the top in order to have that component no longer. Okay, let's see. We're gonna see that now this has a constraint. So keep in mind that even though I press Ctrl Z, we still have this constraint for that component. If I'm gonna select that component, it will be called body. So we're gonna see the coincidence between those two. We see this one, so this is between the body. I'm just gonna delete this one because this was as well not well defined. And now we can see that I can move that. So you need to pay attention when you are dealing with assemblies within CATIA. And let me position this now, so it will be this edge should stay on that edge. And now we see that that is correctly added. Now I'm gonna go with hide and show and hide that. And I'm gonna select that this edge should be coincident to this edge. I'm gonna send that back with hide and show. And now we see that it is currently well defined and we can no longer move that. And it is within the intended position. But we still have this component in the back. So I'm gonna hide this, go with coincidence constraint, and I'm gonna select this edge should be coincident with that edge. And I can also align it over there. That means that we're gonna have this edge should be coincident with, let me not make a mistake again, with the top one. Hide and show that, and we're gonna see that the part will be in the desired location. Now, within the pre-existing model that I added to GrabCAD, there's a little gap. That means if I'm gonna go with measure between this side and this side, we're gonna see a distance of 775 millimeters. And on the other side, we're gonna see that the distance will be 0.8. So if I will go and measure this between, you're gonna see that the total distance will be this one, so the minimum distance. If you want to add some more precision, we can go up to Tools, Options. Afterwards, for general parameters and measurements, we're gonna have the units, and we can increase the decimal place for read-write numbers. I'm gonna increase this to 6 from 3. And now if I will go and measure over here between that and this, I'm gonna see that we're gonna have 47 at the end, and on the other side we're gonna have 8001 millimeters. So now if you want to keep those at a specific distance, we can use the offset constraint in this case. That means that I'm gonna select the offset constraint. Afterwards, the part that we want to constrain to the other part, and we're gonna see that we're gonna have this distance over here. So 0.7747. Now I have the possibility to add the other distance, which is 801, and afterwards I can select everything, add to parentheses, and divide those by 2. And if I'm gonna press tab, that will update the local value, and in this case we're gonna see that this will be the distance. And if I'm gonna measure the distance from the other side, so from the plane to plane, just like the offset, we should have the same value, and we do have the same value. So keep that in mind that by default, CATIA precision is only set to 3 decimals. So Tools, Options over here. And in this case, the value was rounded up. So you can change that to something like 6, and then you will have more precise alignment and measurements between your components. Okay, so we define that this part should always, so this plane should always remain at that distance towards that plane. And now we need another constraint in order to keep the component in check. I will go with constraint, and I will select the bottom edge with this one. And we just saw that this part was as well slightly, so some millimeters, the part was misaligned. If I'm gonna undo that and I'm gonna zoom in, you're gonna see that we have a slight distance. So this is within the original model, and this is why I'm using this for the case study, in order to fix all those alignments, so that you will also better understand CATIA assembly design. Okay, we're gonna move forward. So for the upper part, I'm gonna go again with a coincidence between the top edge and that edge of that component. And now we can do the same with an offset distance. We can again measure those if you want to, but I'm gonna just leave the default offset value over here between those. But if you want to, you can do the measurement and exact offset alignment. For the following components, we see that we have a little gap over there, so I'm gonna put that component to that plane. And afterwards, again, I'm gonna go with the same coincidence. So now we see that this part is a little bit offsetted. So I'm gonna slightly align that, even though we're gonna have the gap at the middle, just as on the bottom section. I'm gonna leave it like that. And for this component as well, we're gonna maintain that offset, so between that face and that one. We're gonna see that it's the same offset value, so we can just use the value that we already measured, which is this one, and they should be at the same alignment. Afterwards, we know that we want this edge to be over here. And again, for this component, we are gonna maintain this offset. So we see that this is redundant since it's already added. So I'm just gonna cancel that. And if you're gonna move forward, we're gonna have now this upper part that we need to constrain. So it will be that edge should be coincident with the other edge. I'm just gonna hide the part to make it simpler. And now we see that this is all just one part. So that's my bad. This is the half fork. I tried to constrain this small component to the other one, but it's the same part. That means that we can go to the steering wheel, which for the axis of components in CATIA, you will always find the axis on the width of the circle. So we see the half circle over here, okay, and if I'm gonna move my mouse on the width of that, so we see the profile and this will be the extruded direction, we are gonna find the axis over there. And I know that the axis over there should be coincident with the axis in the interior side. So again, I'm moving my mouse cursor within the middle area. I'm gonna go back to hide and show, have that position over there, and now we can just align the position where this element will be. That means that I'm gonna maintain an offset which will be this one from the bottom part. Okay, we see that this wasn't modeled perfectly, so we have a little bit of overlap over there. We're gonna discuss about clashes and stuff like that, but not within this basic CATIA assembly video. So if I'm gonna try to go and manipulate this with respect to constraints, I'm gonna move this, and I'm gonna see that some of those Lego parts are not fully defined. So we see that we have this problem. That means we can easily just add a plane. I'm gonna hide that component, and I'm gonna put a coincidence between this bottom plane. I'm gonna go to hide and show, and this plane. I'm gonna send that back. You're gonna visualize. This is also a main advantage. If you're gonna send that back, you will visually see that those will be within the same plane. And now if I will try again to manipulate with constraints, I'm gonna see that I can move the wheel over here. And also for the bottom part, we still have the same problem. We need to define a plane. And we're gonna do the same approach. It's always important to cancel the last manipulation so that the components will go back to their initial state. And now we have the coincidence between the top part of this Lego brick with the bottom of this one. I'm gonna send those as well back. And now if we try to manipulate, let's see, if I'm gonna move this on the y-axis, only the wheel will move. So this is the main objective of this Lego car, that you assemble all the components and they should only move within the desired, let's say, direction. So in this case, we know that on the y-axis we want to move this. So I'm going to cancel that, and we're going to proceed to the other side of the car. So this will be a longer video, but I highly encourage that you will download the file and you will try to do it. And you're going to see that this is the best practice. If you directly work on those components, you know what exactly you are looking for, and you know the constraint commands. You just need practice. So I will select this edge at the back. Again, I will have those repositioned because initially it wasn't properly aligned. Okay. I'm no longer gonna put a plane because we know that if I'm gonna rotate, so it's better directly to put two edges. That will limit that movement. So now I want to select that edge, and I saw that the software didn't allow me to select that, so I zoomed in and now I can properly select it. And that will be the edge. I'm just gonna move the top part as well, and afterwards I'm gonna see where exactly will that part align. So we have that. Again, another constraint between those two. I'm gonna hide and show one component in order to properly have access to that selection. We're gonna have, I think, the same offset over here between these two parts, just like we had in front. So we see this is a side with 801, and the other should have the other offset. So we see that those components are not properly aligned, and we know the value because it's the same value as here. I'm gonna double click, press Ctrl+C to have that copy, and we are gonna maintain the same offset between the inner part and the interior of this one. And I just pasted the value, and we see that the part slightly adjusted. Now I'm also gonna put over here edge to edge. So that piece should be fully locked because we have this offset distance and we have that edge. But now we still need to address this part over here. And to do that, I'm gonna constrain the bottom elements and slowly go upwards. So we have that edge with this edge. For the upper part, again, edge to edge. We see that we had that edge to edge, but the part didn't actually move. So that means that I'm gonna initially position these two planes. It's also important the order of alignment. If, for example, if I would go and select this small edge the first, afterwards the second one, we're gonna see that the initial selected part will be moved towards the other component. And if I will do this in the reverse direction, so initially this part, afterwards the other one, again we're gonna see that in this case, since this part is already constrained, it will again bring that part. So keep in mind that also that is important if there are no constraints between those, but if there are some constraints, we're gonna see that the part will be moved. Again, over here we have some overlapping geometry, but we are ignoring that for now. We just need to add this offset, that between this, and have that pasted. And let's go over here to this section, and we know we have the axis, should be with that axis. We saw a slight movement of the part, and the inner part of this cylinder should be on that outer part of the other cylinder. And now we only have this flag. So again, we're gonna find that axis for the cutout over here where we have the extruded direction of the part. Should be similar to that one. And I'm gonna add an offset. So I want this upper surface always to be parallel with the bottom one and at this distance, so 36.62 millimeters. Now I'm gonna try to manipulate. Maybe I still need to add some constraints over there, but this is why it's best to try to manipulate. And we see that if I'm trying to rotate this, since only that edge is added with no plane, I'm gonna be able to do that. So we need to fix the bottom plane of this part to be coincident with the part for the block with those 4 cylinders. That means I'm gonna hide and show that. I'm gonna go to coincidence, but without having any selection. I'm gonna select that top part to be in the same plane with the bottom. And if we're gonna go back to manipulation, we're gonna see that if I will try to rotate on the z-axis, I can rotate the flag like this. So this is what we intended. But on the other axis, I cannot move that. But if I'm gonna try to move those components, let's see if those are fully defined. and we see that all of those are fully defined. So I'm just gonna press cancel, and you know that the back of the car has been addressed. And now we just have the bottom part with the wheels. So to do that, I'm gonna initially hide the tire. We see that since those were patterned within assembly design, they are all linked together. That means that if I'm gonna hide one, all of those will be hidden. I'm gonna hide this part as well, and we're gonna have the axis over here will be the same with this axis, and we're also gonna have the position. So let me just send the inner part a little bit back to see exactly where this will be positioned. We can make it offset since this surface will be parallel with that one, and we can keep that offset between those. And afterwards, if I'm gonna move the wheel and again add for the wheel the same coincidence. So we had that, but I will also add the plane between this and that, so between the wheel and the tire. If I will try to manipulate the wheel, if I'm gonna update, I'm gonna see that it will snap back into position. That means that the elements are linked. And now if I'm gonna try to rotate this on the x-axis, we're gonna see that we need to go with the forward part and have it linked to the frame of the car. So that means we initially have to define a link between these two. So to do that, I'm gonna add a coincidence. We can also go with the contact constraint, so this will be the same just as coincidence if they are already in the same plane. So contact will keep that 0 offset. So we have that top part over there, and we have this part. Okay, I see that that moved, so that's not within the proper location. As we can see, I've chosen the upper cylinder, but we need this one. This is why it's important to always pay attention to the constraints. So this will be the plane. And usually you will see if there is a problem that the part will move from the original place if you didn't move it. And now in order to keep this aligned with the frame, we're gonna need to make some offsets. So I'm gonna go with offset from this side. I'm gonna go over here and I will choose a side that is parallel with that. So either this or this. And we're gonna receive a value. If we're gonna hide and show the part, we're gonna see exactly on the assembly where that value will be. And yes, this is the correct alignment. And if you want to fully lock this, we can add the other offset as well. That means that we're gonna have an offset. I can use either from the exterior or the interior, since those will always be parallel. We're gonna have this value. That means that the component will no longer move, and we can try to do that if we're gonna go with manipulate. If I will try to rotate this part, we're gonna see that it won't rotate. But for the next one, since we are not fully defined, we're gonna see that we can rotate. So we're gonna address that now. I see that this video is already 34 minutes long, but that shouldn't be any problem. So the same principle will be applied over here as well. That means we're gonna have an offset between this side. I'm gonna go over here and I will choose again a surface that I know is parallel and will be at that exact location. And I'm gonna do the same for the other axis as well. So we know that this I'm gonna hide and show that, go to the hide and show elements, send it back, go over here, will be again that offset. And now if I'm gonna try to manipulate the part, we're gonna see that I can move this around. So that means the axis is not properly defined between the tire and the wheel. And that means I'm gonna go with coincident constraint. We know that this axis should be the same with this axis. I'm gonna send that back. And if I'm gonna try again to manipulate this, on the x-axis, we can still see that even though they will always maintain that offset, there is no plane coincidence between those. So we're gonna need to add that bottom floor with that section to fully lock that. So hide and show, we know that the top surface should be in the same plane with that surface. And if you're gonna try to manipulate the wheel now on the y-axis, we're gonna see that we can have that rotated, and at the same time the pieces are fully locked. And now we just have to position the wheels. So we have this in position directly within the pattern. So let's address this first. That means that I'm gonna add a coincidence between this element and the axis of that one. We know that we also made use of an offset between that section and the section where the wheel will be positioned, which is this one. And we also need to address the tire and the wheel. So that means this will be the axis of the tire, this will be the one for the wheel, and we know the plane where those two should be over there. If I'm gonna go again with hide show, so the same axis, we have the same problem that we had at the back, so we need to properly define those parts. So again, I'm gonna do that. I know that it can be a little bit redundant, that the same elements are being constrained, but I consider that this is the best learning, let's say, scenario for this. So those were the top elements, and now we need to define the offsets. So we know that this part should always be offsetted from that at that distance, and this part always should be from this one. If I'm gonna hide and show that back, it should be in position, and we just have to do the following link between those. Now I see that this is also slightly misaligned, so the bottom section we see over here is aligned, but over here it's no longer aligned. So in order to change that, I'm gonna move the bottom part. So this axis should be on the same with that one, and we have that aligned. Okay, and we just need to define the bottom part to this one, which will use the same offset. So this hide and show, we know that this has those inner areas. We have one direction defined, and I'm gonna go for the other direction. So this with that, we see that we're gonna receive a redundant. So let me make sure that we still need to add only the plane, because the other constraints look to be over there already defined. So we're just gonna define that collision plane. And just as I said before, this contact constraint and coincident constraint will act the same. So I can go with contact constraint between the top part, and if I'm gonna hide and show, that one will be with the bottom. I'm gonna hide and show it again, and if I'm gonna try to manipulate the component, should be locked now, and we see that on no axis those will move. Okay, that's perfect. So that means that also the wheel should move as intended on the y-axis, and we just need to address the other wheels. Now, since they are not directly in position, we can help the software using the manipulation gizmo over here. That means I'm gonna move the component, and at the same time, when I reach over here, I'm gonna rotate it, but I'm gonna rotate it on the proper axis. So in this case will be this one. It's not important that you fully defined it, so I had 5 more degrees that I should have rotate, but it's important just to help a little bit the software in order to make it easier. If you can snap it all the way to 180, that's better. If not, CATIA will deal with that when we're gonna position all the elements. So we know that we had this offset value over here. We're gonna maintain the same value. That means we're gonna have an offset from that area, I think. Yeah. Or is the outer? No, sorry, it will be the outer area. This one, all the way over here, I will paste that value. Okay, and now we just have to position the wheel, the plane of the wheel. So again, we can go with coincidence or with the other one, since they will be the same in this case. And at the end, it's important again to test if our component will rotate on the y-axis, and they rotate both the wheel and the tire. So I'm gonna do the same for these two. Since I already have the compass set to snap to selected by right-clicking and have this checked, I can also do a rectangle selection to get both of those at the same time, move them to position, and afterwards we're just gonna slightly help the software by rotating this. Now I can put that compass back, disable that snapping, and we can do again the coincidence. So we already know that we had an offset between that and this. I'm just gonna paste that since the value was already stored. Now I'm gonna go with the axis and do the same for the wheel. I will just press Ctrl Y in order to redo the last feature, and again that plane with that one. Okay, so now if you're gonna go and try to manipulate, you're gonna see that each wheel can be rotated. Also we can rotate the flag, but the flag should rotate on the z-axis as is currently aligned. And we also can rotate the, let's say, driver wheel on the y-axis. At the end, when you finish, you can press cancel in order to cancel that. And if you want, you can now change also the color of some components. For example, I will select the tires, which are these 3, and we're still gonna have one more, so this. Go at the top in graphic properties, and I will make this, let's say, with that color. I usually prefer not to go with full black in CATIA. In some cases the colors will be a little bit harder to see, also the selection. That's mainly because the edges are currently set to show shaded with edges, and we see that those edges will be black. Maybe over here where we are just gonna have the shading without edges, we're gonna see again that those will be black. But if you are gonna go on shading with material, those black edges will disappear. And this is one of the reasons why I usually prefer not to have the black color, since I prefer to have the black outline of the components. If you want to change the color, you can also right click the components properties, and you're going to find the same graphic properties over here. So we can change that color and have those wheels. Okay, so if you enjoy this content, please let me know in the comment section. I'm also going to position over here to the left a related video to this, and also to the right a subscribe button. So thanks for watching, see you in the next video.